Autoscaling for cost is all about dynamic resource management. In cloud computing, one of the biggest challenges is managing resources efficiently while keeping costs under control. Autoscaling provides a solution by automatically adjusting your infrastructure based on actual demand, ensuring you're neither over-provisioned nor under-provisioned. Autoscaling is a cloud feature that automatically adjusts your computing resources in response to changing demand. It works in two primary ways. First, through dynamic adjustment, where it adds or removes resources based on real-time demand patterns. Second, through cost optimization, where you pay only for what you actually use at any given moment. This eliminates the need to maintain expensive infrastructure during periods of low activity. There are two main types of autoscaling. Horizontal scaling involves adding or removing instances of your application. This is also called scaling out when you add instances and scaling in when you remove them. Vertical scaling, on the other hand, involves increasing or decreasing the size of individual instances. This is referred to as scaling up when you increase capacity and scaling down when you decrease it. Most cloud applications prefer horizontal scaling because it provides better redundancy and fault tolerance. Autoscaling decisions are based on key performance metrics. CPU utilization is the most common metric, where you scale when processor usage exceeds a defined threshold. Memory usage tracks how much RAM your applications consume. Network traffic monitors the volume of incoming and outgoing requests to your services. Response time measures application latency and user experience. By monitoring these metrics, autoscaling systems can make intelligent decisions about when to add or remove resources. There are three main types of scaling policies you can implement. Target tracking automatically maintains a specific metric at your desired target value, such as keeping CPU utilization at 70%. Step scaling adjusts capacity in predefined steps based on alarm thresholds, allowing for gradual changes. Scheduled scaling provisions resources based on predictable time patterns, such as increased traffic during business hours or seasonal peaks. Each policy type serves different use cases and can be combined for optimal results. Let's look at a practical configuration example. Min size is set to 2, meaning you'll always have at least 2 instances running for high availability. Max size is 10, which is the maximum number of instances allowed during peak demand. Desired capacity is 4, your starting point under normal conditions. Target CPU is 70%, the threshold that triggers scaling actions. Scale out cooldown is 300 seconds, a 5-minute waiting period before adding more instances. Scale in cooldown is 600 seconds, a 10-minute wait before removing instances to prevent premature scale down. Autoscaling delivers significant cost benefits. First, it reduces waste by eliminating idle resources during periods of low demand. Second, it ensures you can meet demand by scaling up instantly when traffic spikes occur. Third, it right-sizes your resources by matching capacity precisely to actual workload needs. Finally, it lowers your overall cloud bills because you only pay for active compute time. These benefits compound over time, leading to substantial savings compared to traditional fixed-capacity approaches. Following best practices ensures effective autoscaling. Always set appropriate cooldown periods to prevent rapid scaling fluctuations that waste resources and money. Continuously monitor your metrics and adjust thresholds based on actual performance data and usage patterns. Test your scaling policies thoroughly under different load conditions before deploying to production. This testing helps you understand how your system behaves and allows you to fine-tune parameters for optimal cost efficiency and performance. Avoid these common mistakes when implementing autoscaling. Setting aggressive thresholds too low causes your system to scale up unnecessarily, wasting resources and money. Flapping occurs when rapid scale-in and scale-out cycles happen repeatedly, increasing costs without improving performance. Ignoring minimum instance counts can leave you underprotected during failures. Always set realistic minimums that ensure high availability while balancing cost considerations. Understanding these pitfalls helps you design more effective auto-scaling strategies. The cost savings from auto-scaling can be calculated using a simple formula. Savings equals peak capacity multiplied by hours minus actual usage multiplied by hours. In traditional infrastructure, you provision for peak capacity and pay for it constantly, even during low usage periods. Auto-scaling eliminates the gap between provisioned and utilized resources. By scaling down during quiet periods and up during busy times, you pay only for what you need, transforming your cost structure from fixed to variable and dramatically reducing waste.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.